Hi, Cam 141. So just kind of finished up talking about ionic dot structures. That's kind of the segue into Lewis electron dot symbols. So, um, and they're good for drawing molecules like caffeine or cholesterol. So, if you kind of have familiarity with the periodic table, with the number of electrons that certain atoms have on their outer shell, you can come up with these electron dot symbols. So these are for the first 20 elements. Organic chemistry mostly uses carbon, nitrogen, and oxygen. So those are the ones that are mostly shown in Lewis structures, but you can have other molecules in Lewis structures as well. So let's keep that here for reference for us. The ion formation and the octet rule are kind of what drive Lewis structures. So with covalent bonding, the atoms will be sharing electrons. So we'll talk about that a little bit. So in ionic bonding, it's a complete transfer of electrons. But with covalent bonding, it's sharing. So the nucleus will be attracted to electrons, but the electrons repulse each other, and the nucleus repulses each other. So there has to be this kind of balance of a cloud of electrons in the interior so that the atoms will hold together. So it kind of acts like glue. So covalent bonding with the hydrogen molecule is here, shown. Two hydrogen atoms. They're simple with the n equals 1 for the energy level, one shell, one electron. And so they want to have two electrons, the atoms in the first shell, so have like a Nobel gas configuration like helium. So if these two electrons come together and share, then each atom has two electrons essentially. So that's what makes the bond. And you can see the proton is pulling electrons, and they kind of equally share that electrostatic charge pulse thing. So you can think about this with terms of methane too. So if you have carbon, carbon has 4 valence electrons. Show that periodic table again. So you can see here's the periodic table. 1, 2, 3, 4. 4 valence electrons. So you can put those as little dots. 1, 2, 3, 4. Well, carbon wants to have 8 valence electrons like neon. Neon would have 8. 1, 2, 3, 4, 5, 6, 7, 8. And they're both in the n equals 2. So how can carbon get that? Well, one way might be to have hydrogen come along with its 1 electron. And carbon's got its 4. And if you put 1 hydrogen on each side, then you can draw a little line between the electrons. And that's how you get methane. That's what methane would look like on a really simple Lewis structure. And then you can redraw it without the little dots like this. Okay. So that's kind of sodium chloride is an example of ionic, and then carbon dioxide might be another example of covalent bonding happening in Lewis structures. So Here you can see the 4 covalent bonds on carbon that'll make the carbon happy with its octet. And nitrogen, it tends to form 3 covalent bonds and have 1 lone pair. So 2, 4, 6, 8. Oxygen, 2 lone pairs, 2 bonds, 2, 4, 6, 8. Notice in common though, they all have 8, except hydrogen's happy with 2. 2 electrons, 8 electrons, 8 electrons, 8 electrons. And same for the halogens, 2, 4, 6, 8. 8 electrons. So to do Lewis structures, how does this work? We have different types of covalent bonds. You can have single bond or triple bonds even. So how do we get these structures? Well, if you count the valence electrons, like bromine, 1, 2, 3, 4, 5, 6, 7, then put the hydrogen in here. Boom, there's your HBr. So the Lewis structure for that. You can see this is done for sulfur, and here is nitrogen. Sulfur has 2 unpaired electrons because it has a valence of 6 electrons. So it has 2 sites for hydrogen to come in. 1, 2, 3, 4, 5, 6. So hydrogen will come in with its 1 here and 1 here. And so now sulfur has 2, 4, 6, 8. So H2S would be another example of covalent bonding on a Lewis structure. Okay, so Lewis structures of compounds, how do we do this? So to write the rules, 1, determine the number of valence electrons. 2, write the skeletal arrangement of the atoms. 3, subtract the number of electrons for the bonding from the total valence. And then 4, distribute the electrons. If there's not enough, then you have to rearrange the electrons. Okay, so let's do some examples of this. So here you have H2O. So step 1, determine the valence electrons. Hydrogen has 1 valence electron. Oxygen has 6 valence electrons. There's 2 hydrogens here, so you multiply that times 2. So you have 2 valence electrons for hydrogen, 6 for oxygen. That's 8 valence electrons. So now oxygen's in the middle. 1, 2, 3, 4. There's 2 hydrogens. Boop. So the way to do this is draw the skeleton arrangement first. So we have 1, 2, 3, 4 electrons used up. So then you subtract that 4 valence electrons. So that would bring us to step 3. So step 2 is writing the skeletal arrangement. So again, 8 valence electrons. Keep that in mind. And then step 3, subtract the electrons that were used. So HOH, there's the 2 electrons for each single bond. So that's why we're subtracting 4. So you have 4 electrons left to complete the structure here. So 1, 2, 3, 4 electrons are left. So that's how you place them around the central atom. And so then you end up with H2O. It has its full octet. 2, 4, 6, 8. And then hydrogen is happy. It has its duet, so to speak. So that's how you do water. let's do one more, carbon tetrachloride. So carbon has 4 valence electrons. Chlorine has 7 valence electrons. There's 4 chlorines, so you multiply times 4. So 7 times 4 is 28. So that's a total of 32 valence electrons. So carbon will go in the middle because you see the 4 chlorines. And then write the chlorines all around here. So notice that for each single bond is 2 electrons. So we wrote the skeletal arrangement. So that's step 2. Step 3, subtract the single bonds. 2, 4, 6, 8. 8 electrons. So 32 minus 8 is 24 left. So then we have to place those remaining 24 electrons around the carbon. So 32 minus 8, because our 2, 4, 6, 8 is 24 valence electrons. So just place them around. Normally in pairs is how you do this. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So that works out nicely. You can see the chlorine has 2, 4, 6, 8 electrons, and the carbon has 2, 4, 6, 8 electrons. So our final Lewis structure will look like this. And so that's CCl4, carbon tetrachloride. So I hope that helps. This is an introduction. So there's some practice problems.